morning. I'm Dave Thomas, and I'm the track host for the Wild Card or Strange Blend track today. Very fortunate to have a lot of good speakers. They just stuck an old guy in at the beginning, probably to be charitable. So this track started out, at least part of it, about legacy, and so they called me up because I'm old, and I said, sure. I mean, I don't work specifically in this area, but I work with a lot of people that solve problems, and I used to work extensively in this area. Today I do high performance analytics, but it still ends up being inserted in a lot of interesting legacy places because there's so much valuable data there. And then Feathers decided that he was tired of legacy, so he switched his talk, and things rippled. So now we have a wild card track. Anyway, that's the true story. So anyway, so what I'm going to be talking about is the challenge that most people have, which is how to take an existing code base, which is actually producing money for your corporation, in spite of all the terrible things that are in it, or perhaps because of all the great things that are in it. Michael, of course, talks a lot about legacy code and is an expert at it, and we're very good friends and worked together for many years. I just never found that his approach really had a great impact on developers and how to do development properly, but it didn't really deliver what the business wanted with the legacy. So that's really what I'm going to focus on. That's really the outline. I'm not going to say much about typical code-driven approaches because that's really what the technical debt, the people who rant and rant. You know where technical debt comes from, right? That's basically you have agile teams. They write code without doing any design or thinking quickly, and then after 10 sprints, start whining for technical debt cards. That's certainly my experience. Agile development creates technical debt faster than any other process I know. So I'm really going to focus on a data-centric approach, and it's going to give a bunch of examples of different businesses where this has been applied. Many of them from my own experience, but I also a couple with some people I've worked with that you might know. So I'll talk a bit about how you get management to agree these things, because inserting new technology into core systems is not always something that's easy to do. I won't spend a lot of time on that. And I really want to focus on just going through some classic innovation opportunities, places where you can insert new technology and make a difference. So we all know what a legacy is. Most cases, they're important because lots of value there. And basically what you're trying to do is unlock that value and enable it so you can add more value quickly to the business. Improve access, federate the data, change the functionality, either because you want to, or if you're regulated because you have to. Many organizations have backlogs in some industries, like banks, of our backlog is sorted by the size of the fine if we don't fix this. The people in the banking community are not laughing. It's really a serious problem. Time and cost of process. Now, there's lots of things that people do that they want to basically improve maintainability and reduce technical debt. I actually don't believe that. In the end, it's systemic change is really hard and usually doesn't ever get finished. So it starts off with great excitement and pride, and people do great things, but they usually run out and they get exhausted. And modernize to retain and attract technical staff. Well, if those technical staff are really going to go, they're unlikely, if you're in a legacy organization, to be excited just because you told them to program in Scala and then they can't do anything much with it because all the other systems constrain them. You know, I've watched so many people, basically go to Agile and have no CI and no automated tests that basically it just makes you cry. So I think we all know what these things are. Basically, pretty straightforward. And of course, we know that there's classically a number of solutions for this. And the solution, of course, can be provided by your consultant, your outsourcer, or your new super duper team of hot Scala guys. So I'm not picking on Scala, F#, whatever, pick whatever it is, microservices. Whatever you saw at GOTO, you're going to go back and cram it down the throat of your organization as a magic fix. You just drink this, right? In practice, any of these systemic changes take a huge amount of time and cost a huge amount of money, and in most cases don't work. Typical code-centric approaches are, we'll rewrite it all in our new favorite language. We'll put it onto a new platform. We'll outsource it until we have to insource it back again, which is really exciting to see people realizing that putting a development team in Iowa is a lot smarter than locating it someplace that you can't talk to anybody across time zones. We'll Agile and TDD it. A great idea, basically you have this very small, toothpick and a hammer working on, legacy mountain. Good luck. Or just make it all microservices. And of course, you can take a wonderful tool like Sonar. Sonar is a very good tool. And you can look at your legacy code and you can see, and this is a very simple picture. Yours is much messier than this or much denser. And you can see what you have to do, and you can go to Sonar and you can snip some of these dependencies and you can see the code open up and so on. But what you really want is a big button called Fix It. And that's the hard part. So refactoring is actually a joke because there are no serious refactoring tools for large code bodies. Right? The other problem is the refactoring is a lie because it's never equivalence preserving. If you had the test, you could be easy to refactor, but you don't have the test. The other thing is you've actually told your management, we're just going to refactor it because that sounds like an easy thing and it's good. But in practice, you're going to rip the hell out of it, change it, rewrite the code, and build new tests. But you're not telling them that because that's a big R risk. So in general, we're looking for something that's different. And what we want to do is avoid big bang system changes, and in particular, the focus on systemic changes, making everybody do whatever it is, move to functional programming, use structured programming, you pick whatever religion that's been hyped, microservices, teaching everybody to go to Scrum, basically is a way to take the small amount of money you have and spread it very thinly across your organization with very low actual substantial impact. Maybe you get 10%, right? And everybody feels better. But it doesn't really do because the reason executives bought the word Agile, why? Because it sounds like agility, but it ain't. What they want to be able to do is deliver more stuff faster. And Agile just doesn't have anything in the contract about speed. And typically, anything you're going to do is going to ripple across very, very large things. So basically, the surface area that you're attacking is just too large to do anything interesting in the most important time period in a business, 1 quarter. So instead, I'm not coining VDD, What you want is an approach that's focused on value. I mean, the whole point of Lean, which was the inspiration for Scrum and Agile, not that Kanban or Scrum actually resemble anything that actually happens in Lean for the most part, is really how can I do something simple that makes a big difference in a short period of time. And so typically you want to choose those projects which are very narrowly scoped. And if they are code focused, you want to make sure they're really focused on some very, very small piece of the code. Otherwise, it's much easier and in general delivers much more value to pick things that are focused on data and data flows. And you want to put a small team of key skills on a specific tactical target. And you want to time box that work to 3 to 4 months. And you want to make sure that it's got measurable value and a measurable SLA. The other thing we'll come back to is you also want to make sure that you can actually insert this into production, into a live production environment without disrupting the operations of the business. So these projects aren't necessarily easy to find, but having this set of criteria throws out a lot of the goofy ones right away. So the other thing you want to do is leverage innovations, because very seldom do you get better than somebody else or your competition by doing things the same way. If you're doing best practice, which is everybody else's best practice, you don't have a better process. You just got a copy of everything else, everything that everybody else is doing, probably not all that well. So if you're going to make something go faster, and if you think of this from the manufacturing or lean point of view, that typically means you're going to accelerate either the people's capabilities to do things, or you're going to automate with machinery of some form so you can improve the flow. Lean is really about flow and increasing knowledge. The easiest thing to do is change the business, right? No code required. Many people ignore this opportunity. There are lots of things you can do to change the business. I don't have time to go into these because this is a technical talk. But the easiest thing is often to go and discuss, if we did this and did this, we could save all this money, and with the changes we have to make to our systems are trivial. As technologists, we often don't even bring those forward. Well, maybe because we want to do everything in microservices and program and go, I don't know, whatever. The other thing, as Joe mentioned, is hardware always saves lousy software. Hardware today is dirt cheap and very fast, much, much cheaper than programmers. Today you can buy a machine with 1 terabyte of RAM, probably 100 terabytes of storage of disk, 10 terabytes of non-volatile memory, 64 cores for probably the order of $12,000. You can do almost zero with a programmer for $12,000. Think about it. What do you do when you can put all of the interesting data you have in memory, and you can actually query it brute force by just searching memory? Hardware is very, very important and almost always gives you very quick leverage, whether it's testing and CI or whether it's into the core part of the system. The other thing, of course, is better software technology. And here's, of course, where you can vouch for, we can use Scala, right? We're not sure what it is. It's both a floor wax and a dessert topping, but we can do both object-oriented programming and functional programming and DSLs together. Have fun. Try and separate the concerns. Make sure your functional programmers understand functional programming. Make sure your infrastructure programmers know how to do it and layer your stuff. Scala is a very powerful technology, as is F#. But the challenge. And improve software practices. This is probably more important than technology. Is basically property-based testing. How many people here do property-based testing? The rest of you should just leave. Folks, property-based testing was invented like a decade ago by John Hughes. Yes, it was in Haskell, which you're not expected to learn. But it is best practice in the industry for writing tests. Finds way more bugs than other things. Let's get off of unit testing. Unit testing is good, but let's make sure that we have property-based testing in this first class. Very, very important. Immutability and new programming models. These are big things to look at. Okay, so we're going to insert some wild and crazy stuff into the middle of somebody's core system. And we're probably going to do this every quarter. So we're going to basically have to deal with some probably pretty questionable, difficult questions from our executives. So the first thing is, basically, if this thing is in our experience, that we can't return like $5 to $10 million by doing this to the business, then it's kind of, well, why bother? Right? Or let's say greater than 15%. Because you can just train everybody in Scrum and probably get 8%. Right? No one will know where it is, but someone will be able to study it. You want to the other thing is that if you can find a point where you can do this, you can find the business executive who owns that problem and basically have them step up to doing it, says yes. The other thing is you want a short timeline, 3 to 5 months. Ideally less than a quarter, but you never get it quite right. It's an estimate. Notice an estimate has at least 2 points. Oh, you still do story points with 1 point. No wonder you don't understand the risk and can't measure your large projects. You want minimal impact on the day-to-day business because it's got to keep running. If you have to stop the world and change everything, that's not going to go well. And you need a strong business sponsor, which is no surprise, but I put it on there in case you think you can do it without one. The technical thing is you need a small team with technical and business track record. Most companies don't have a lot of these. And that's one of the reasons we only do small projects, because probably in most large organizations, we can only find maybe 3 to 5 teams of Green Berets, Navy SEALs, who actually are skilled enough and have the guts to actually take the stress of doing these kinds of insertions. You can build them. You put new people in. After you've done 2 or 3, you get better at doing this. But these people are going under fire, lots of pressure. Probably if you don't deploy, you could lose your job. Or at least you'll be, you were the smart guys who said you can do this, and you'll have to suffer in purgatory or go to a better company. You will need specialist skills because sometimes you may have to find out that you have to embrace something like SAP BW, right? So there will be a billion tables that don't make any sense to you. So you need a SAP BW expert, or you are going to die. So you need real expertise. We're not going to learn this on the job, right? This is not one of these kind of agile things. Well, we'll just learn it as we go over 400 years. Right? You want localized changes with minimum dependencies. You want a proof of concept. Of course, everyone knows about proof of concept. And anyone who wants to insert a new technology is great at doing a super demo. That's not a surprising idea. The thing that's important is the next one. Can you actually lean on your demo with all the real data and load and not have it fall over? Right? You pick this wonderful new framework or this wonderful new programming language and you feed it 500 records and everyone, or maybe you feed it 1 million. But when you actually feed it the real data, the whole thing just falls over. So you have to actually run the thing and test it at scale. And you have to do all these things in weeks. So it means you really have to understand and have a narrowly scoped problem. Fortunately, there are lots and lots of these, but people don't look for them because they're trying to do something big and systemic. And also some people are afraid of actually having a deadline and actually doing it. When you get used to this, it's kind of like drugs. Shipping, those who ship are very different people. If you've never shipped software, I really feel for you, right? But when you're used to building products that have an impact, it's like an addiction, right? You want to have very straightforward DevOps because otherwise, and something I think is very important, even though property-based testing and so on, if you can, have an independent test team or an independent validation. This is a very old practice. Todd may mention it later in his quality talk, but having 2 teams write the same software or one write the validation of the other independently is a tried and true technique. So selective code focus, I think people talk a lot about this. My point is keep it very small. The small computational bottlenecks often, Martin will be talking later, but I won't be talking specifically about that. Often Martin will go in, do some things, find a few lines of code. He was talking about one yesterday where he moved, I think there were 10 lines of code and he moved one statement, 7 lines and got 18% improvement in performance or something like that. Very, very small focus by using instrumentation. Places which change a lot often kill people because there's tons of case statements and if statements and so on. Burn those, make it more table-driven or rule-driven. That's often a transformation, can be done very successfully. The other thing is that the rules are typically data-driven. It's much easier to change data than it is to redeploy a jar. Right, you can do it on the fly. This is proven in process control, command and control, been done for years. It used to be called table-driven programming. If you're as old as I was, that was a badge of honor. You know, if you actually wrote all sorts of procedural code that bloated things up, people would go, wrong, son. You know, here's this little table, 3 tables, a small interpreter, and things really screamed and were easy to change. So points of high variability. But what I really want to talk about is not those sort of code-focused ones, and that's just the things I went over there. I did put DSL on here. DSLs are a good idea if they're going to make a big bang in your organization and you're going to keep 2 people in the organization who are going to maintain the DSL. There are DSLs, for instance, in various industries that make a big difference because they allow end users to build or script, fabricate the application, but only if you keep 2 developers maintain that DSL and you really focus on it. Language design is hard. It's the next hardest thing after frameworks. That's why frameworks are a mess, because most people can't design languages, and frameworks are the first step towards a language. There's some, obviously some speed up from hardware, but I don't really have time to want to focus on that. So what I really want to talk about is kind of a lean data flow centric approach, because this is the one, in my experience, which gives you the biggest bang for the buck. And so what we want to do is focus on targeted opportunities for high value. The biggest thing in the organization that sits there, and often the thing that's hard to change, is the data. And it's very stable. Unlike the code, which is often kind of messy and so on, because data persists and it isn't that easy to change, and you've got nice database administrators who prevent you from changing it even if you want to, you basically have well-defined file formats and data formats. So you have something that's actually a fairly easy target to deal with versus trying to work with code. Data transformations is the primary function of IT. And here you go. Now you can bring out your functional language, right? What's functional programming about? It's about doing data transformations. Not really much about parallelism, unless you're doing things like Joe does, where, of course, Erlang's amazing. And it's often the easiest place to insert things because of these points where data flows or data is stored, and so you can do it. It's also easy to test and monitor because the data actually stops at various points, and you can compare it to see whether it's the same or not. So these are kind of ideal places. So there's lots of these. Where's data being stored at rest, retrieved from at rest, or where is it moving along? All these points, right? The persistent data, data moving inside the hardware level. It's a great place for functional transformers because they're all just maps applying functions to the data. If you want to use heavyweight hardware, there's places where you can use this if it's appropriate. GPUs are a wonderful technology. The only problem is you have to move the data from CPU memory into GPU memory and back, and that can often take more time than it is to actually run the computation on the GPU. That's why GPUs are not yet generally useful. The other thing, of course, is you can use sync and replicate, because working on a copy of the data is much easier than working on the live thing. So that's, most people know that if you're silly enough to use something like a NoSQL database and stuff everything into a blob or a JSON WAD, and then every person who wants to use the data has to parse it. Thanks a lot, you lazy programmer. Yeah. I use Mongo, so it was easy for me, so I could screw the rest of you for the rest of your life writing report programs. So one of the tricks there is very simple. After it's stored in Mongo, we replicate the blob stuff out into a Postgres database or something like that. Very simple idea, but makes reporting easy. So let's look at some what I call legacy innovation patterns. And there's lots of these. I just want to go through some. Make it a table-driven. Actually, let me. Yeah, that's fine. First thing is make it table-driven to accommodate variability. Lots of things for this. Decision tables. You can ask your granddad about those. They're really powerful, really simple, and normal people can actually fill them out. And they can be interpreted very quickly. State tables or state machines, for workflow, things like that, get tracking. Rules, constraints, constraint systems. A spreadsheet is a constraint system, right? Basically, when you change this, it changes that. So these are examples that you can use, and a simple case study. A major HR system. Basically, one of the problems with HR systems, pensions and benefits, is that these pensions and benefits are negotiated with a large union or a large collective representative body. People, sit in, dark rooms arguing on both sides with some poor people on either side of, glass, sitting there on spreadsheets, putting in whatever they say. Yeah, you can, right. In Colorado, when hunting season's open, you get that day off. It's a deal, right? So there are tons and tons of silly rules, or maybe important rules. I'm Canadian, so that are important to you to basically capture these. So they get captured in the world's most powerful tool, Excel, right? And then all these Excel, and of course there's a deadline because once the contract's signed, you have to have the new benefits package in operation within 60 days or something like that. And the problem, of course, is this benefit system runs on a legacy technology. And so what you have to do is insert all these rule changes into the code. And you can imagine that code's written in a really clean, easy to read programming language. And it is. It's written in COBOL or PL1, which are both actually pretty readable languages. Maybe not to you. So this turns out to have a lot of errors. Now, of course, when this first was tried, we put in a team of skilled, crack, object-oriented programmers. In fact, one of them was Kent Beck. And they showed that they could get 10% by redoing it in an object-oriented programming language. 10%, yawn. And still a fairly high bug rate because testing these things is hard. And just before they left, embarrassed that they only made it 10% different, despite having one of the world's most flexible and rapidly refactorable programming languages, they went, aha, the rules are all in Excel. But these Excel sheets are buggy. So suppose we write a rule checker for the Excel sheet. Right, and it'll throw out errors anytime it finds any errors, and the analyst will have to fix these because we're not taking, garbage in, garbage out. So one programmer wrote the checker using this wonderful programming language they were using because it was fast and refactored and pretty good for writing that kind of application. Secondly, another programmer said, well, I could write a data flow interpreter or constraint evaluator, and that's the spreadsheet. And I could just deploy it in the mainframe, and I could have COBOL or PL1 call it. You can still do that even with old programming languages. Calling still works, right? And poof, all of a sudden they can now replace 100 developers with 2 that are maintaining a kind of a DSL sort of thing. And that code is still running today, been modernized. And I've seen this trick used, I've used it at least 50 times. Today, you can run spreadsheets to run your entire business. Right? We run routinely on trillions of rows of data running through spreadsheets. Cyber analysts using spreadsheets to look at this, right? So, a very simple technique. Another one is make it look like the web. This is the process control. Process control is a very proprietary industry. They actually modify the hardware, so they can patent it and make it different. So they take a standard VME bus, switch the pins, and do horrible things like that, and then patent it as an improvement, right? This is, Rockwell, ABB, nasty stuff, right? Like the telcos years ago. So the whole issue of open, so this means you've got, companies have easily 300 million of this stuff recorded in their factories. And of course, they'd like to modernize it and get access to it, but they have to get, and of course, then the vendor doesn't quite understand software, so the first 22 releases of the new automatic process control system really sucked. So they're completely locked in. Well, first of all, we need a little hardware. We're going to put a TCP/IP in there and so get rid of these proprietary protocols. So we're going to put a board inside one of these process control systems, and we're going to open it up, take the packets off the bus, TCP/IP. 1 or 2 hardware engineers, easy project, standard TCP/IP. And then we're going to take everything that's in the process control system, and we're just going to turn it into atom feeds. By the way, this works for all old mainframes. Everything that IBM has, and DEC and so on, today you can get an atom feed for all the journals and so on. Much easier than building some goofy API field of dreams, right? Here's another 100 APIs, see if you can do anything. Just expose the data. As soon as the data is exposed, now you can put your Websters on it, and they can build apps that can consume, visualize the data, and so on. Very simple trick. Takes $300 million worth of hardware, makes it instantly available in a modern way. One of my favorites is, you only really need one API, folks. It's called Select. Right? So use this trick for MRP systems where the data is locked in, put an ODBC interface in front of it. All of a sudden, everybody can get reports out of a database that nobody could even use. Many MRP systems use very contorted sort of network or object databases, very strange structures. This is an easy way to do that. Microsoft did it with Link, basically turn everything into a collection. That's one of Eric Meyer's tricks. And if you've seen more recently, I've been screaming for years that why do people have all this goop they're passing to these zillions of poorly defined REST endpoints they call APIs. And finally, Facebook, something good from Facebook, is the notion of GraphQL. Basically, in the end, all you're doing is selecting. So just push the select across the wire. I'll talk about select injection, SQL injection and all those sorts of problems later, but that's a problem you have to solve anyway, and your security for all your REST stuff is really a mess anyway, even if you're using an API gateway. Functional transformer is another one. Let's move to some others. Well, today, memory is really cheap. You know about NVMe memory? NVMe memory is a new type of memory along with 3D XPoint, basically that allows you to put essentially 3 terabytes to 10 terabytes of non-volatile bus addressable memory on your laptop. Within 3-4 years, you'll have a petabyte of memory in a rack. These are 3D non-volatile RAM chips. Right. Why are we struggling with all this stuff? Right. Leveraging memory, algorithms become much, much simpler. You can do things very, very quickly. If it's non-volatile, a whole lot of stuff for traditional databases goes away. Atomic read-write sets, you don't need to worry, it doesn't fail. Intel says that if you kick the power plug out, the writes will even complete. Simple streaming your data flow, we know about that. Basically, if you look at any Fred George's stuff, he did it forward technology and so on. What he's really done is gone back to data flow. That's called structured analysis design. You can ask your dad or granddad about it. Right? They're just processes that take data and consume it. They're not back and forth. They're not complicated microservices. They're little services that typically pub/sub. And that's something that's been used along with RDBs and batch databases in the finance industry for years. Basically, go with immutability, keep it all, much, much simpler technology, much easier to do. Today with sexy names, event sourcing, but an old technique that's very, very powerful. And batching is still the best way to get performance. If you process everything one transaction at a time, you will have a slow system, right? Most high-performance systems process batches of hundreds to potentially thousands in one fell swoop, rather than trying to pretend that they can be fast enough with zillions of threads, because they won't be. And I'll let Martin, if you ever want to talk about why threads are a really bad idea, you can talk to Martin or Todd. And I mentioned already, get beyond TDD, right? Or add property-based testing to TDD. Enhance your TDD. Right? And independent testing, I'll just talk about one thing. Part of this manufacturing problem, first of all, we basically liberated the data so that people could write reports to it by putting an ODBC interface in front of it. Second thing we did is basically they were in a database technology that had no future. So the data was locked in. So they had to migrate it and restructure it. Again, it's not the usual thing. Refactoring a database is never about equivalence preserving. You want to first preserve the equivalence, but then you also want to make some changes because you're using a different database technology, indexes, and so on. So the approach here was basically, when you have to move tons and tons of data, doing that by talking to whatever API you want, whether it's SQL or whatever it is very expensive. You can use log files, which is a common approach. But in our case, we had to move so much data, we actually just read the pages physically from the disk. It's actually much faster and much simpler. The database page format is actually very stable over time because everybody's scared as hell to change it. And despite the fact they all should be encrypted, 99% of them are not. So we read the pages physically. We essentially wrote something called a relocating loader or a linker, and basically batch patched all the things so we could actually stream all the data in one fell swoop, make one pass through the database, and convert it completely from one database technology to another. However, this is a little bit risky, right? So what we did is we got an independent team to basically write an implementation that essentially would validate that the data that we were bringing over was the same. And they found a lot of bugs. They were all small because the core algorithms were sound, and they actually reviewed the core algorithms they were using, but they did not have access to any of the source code, and they wrote this thing completely. This is often much cheaper than writing a lot of tests, because you can test the whole thing in batch, and you can test it particularly when it's data, because data goes from this state to that state, and so as long as you can check that those two states are consistent, you can validate. Anyway, that's just a few of the tricks. None of them are surprisingly new, but they work really well. And the big thing is you can implement all these things in weeks to a few months. You can verify they work, you can show them, and you can insert them into the organization with rather minimal impact. And they're much easier than trying to do substantive code changes and have a really big impact. So from my point of view, I love working in legacies because there's so many opportunities that everybody else runs away from, or they have some naive thing like, we'll refactor it, we'll go and change it to this, or blah, 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 rewrite it. When in fact, what you really want to do is go to the business and say, look, I can save you $5 million here, we can save $20 million over here, we can do this. We need basically 10 to 20 people. We're going to build 2 or 3 teams, and we're going to do one of these things every quarter. You'll miss some. We screw up probably 1 out of 3 times, but usually we get it in the next quarter. And the good thing is, because it's easy to insert, if it doesn't work, it just comes out. Now, clearly I've simplified some of the details, but I hope you're encouraged to look for new ways to do things. And as I said, when you actually have boxes with all this memory and so on in it, you can do amazing things with stuff. I have people who basically say, I've never ever believed I would see this data. Right? When you take all your corporate, how much data you have? You don't have very much. I mean, look, we're going to have a board in your PC that's got 10 terabytes of non-volatile memory. How much interesting data can you not put on that 10 terabytes? We're in a world where we can actually replicate the data to every person in the company who needs it. Oh, you're moving it all to the cloud. Oh, well, you just missed a generation. Why are you moving it to the cloud? You could have it non-persistently directly available to all your people. Well, clearly I'm a nut bar, so I'll finish there. Thanks for your time.